Good afternoon. As my colleague mentioned, I'm Vanessa Little. I'm our current TSC chair, the Technical Steering Committee chair for Open Source Mano, and I have been for the past year. So I'm going to walk you through a little bit about the technical architecture of Open Source Mano without going too deep. We don't have to get too crazy here today. But we'll have a little time for questions at the end if there's something that you're particularly interested in. So what is OSM? I think Francisco Javier captured it pretty well, but let me just summarize here that it's a production quality Mano stack. It's capable of orchestrating network services. It has an openly published information model and data model. It's available to everyone, being an open source project. It's suitable for all types of VNF, so it doesn't really specify what type of VNF can be used for it, and it's pretty open and agnostic in that sense. It's operationally significant in that it's able to orchestrate any type of network service that you're able to compose. So more or less any kind of complex network service or very simple one VM network service can be facilitated by open source Mano. So the possibilities are really only limited by your own imagination to be able to compose these network services. And most importantly, it's Vim independent. So it works with the VMware VIMs, it works with KVM OpenStack, it works with AWS. It's a plug-in model, and so as VIMs begin to evolve over time, OSM can fall in lockstep and be able to be compatible with all those VIMs very easily by simply updating those plugins. It's aligned to the NFV ISG information models, but it's capable of also giving some constructive feedback into those models. And what I mean by this is, because this is an ETSI project and we work very closely with the ETSI standards communities, we consume those standards, sort of ratify those standards, and we try to use them in a practical application, and then we send feedback back to the community on what worked well and what didn't work. So in that sense, we have a really beautiful symbiotic feedback loop with the standards community in being able to tell them which standards are working well, which standards need a little more work. And in that sense, we were able to give back to that community and improve those standards a lot more rapidly than I think it normally would be if it was just an academic exercise. And finally, we enable an ecosystem of information model compliant VNF vendors. And so we run a number of initiatives, like Francisco Javier mentioned, like our Hackfest, and like our new VNF onboarding task force that you're going to hear about in later this afternoon session. We're doing a lot of work to enable VNF vendors to be able to work with open source Mano, because as Francisco Javier mentioned, there are a myriad of information models out there in the market today, and a lot of people find that ecosystem pretty daunting. And so we put significant effort and diligence into being able to onboard a VNF very simply and easily and repeatably into OSM. And this appeals to both the operators that are trying to use them and the VNF vendors themselves that are trying to work with the open source Mano to demonstrate their capabilities. So we appeal to both ends of the spectrum, and we find this one of our most important initiatives, especially for this coming year. So when you overlay what OSM actually does onto the ETSI schematic that I think we've all seen to death now, the pink area here is where OSM really plays and what OSM really provides in this overall architecture. So in case there was any confusion, it's the Mano section of the ETSI diagram. And as Francisco Javier mentioned, we have a huge community and it's growing every day. At last check, I believe it's actually more than 110 members because we had 2 more join this week, and I haven't had an opportunity to update the slide. But we've had extremely accelerated growth since our inception 3 years ago, and we're pretty excited to see that the momentum is continuing, and new communities, new operators, new VNF vendors, and new commercial vendors as well as system integrators are joining the community every day. So just to talk a little bit about the OSM governance, because it is an open source project, governance is very important to us in being able to keep some quality and sanity in the code, as well as keep the project moving forward. And so at the top, you see our leadership group, which is composed entirely of members of the operator community, because this is an operator-led initiative, and the whole goal of the project is to create an open source orchestrator that operators will actually use. And so the leadership group drives the whole community, and the majority of the requirements for the next phase of each project is pushed down, top down from the leadership group. Underneath that, we have the technical steering committee. This is the committee of which I'm a chair. Membership on this committee is dictated by how much code your entity or company contributes. And so it is not, it's not a position that you can purchase with a membership. It is a position that is earned through contributing into the community. And this is reviewed with every coming release of open source Mano, so that we keep that steering committee fresh with active contributors. Underneath that are the MDGs. This stands for Module Development Groups, and each of those module development group has a lead. These different groups, and I'll get into the different aspects of OSM, the different components, but each of these groups focuses on a particular component of OSM and manages and maintains the code base for that particular component. And then underneath that, we have our sea of contributors as well as our users. And our contributors can come everywhere from a commercial software vendor or commercial hardware vendor all the way to the academic research community. As Francisco Javier mentioned, we have a significant number of new contributors that are coming from the 5G European research community. This is a really big step for OSM because we have the bleeding edge innovation that's coming out of these academic projects paired with the requirements of the operators that are looking for in-market solutions today, and sort of bolstered up by all of the commercial vendors and system integrators that really want to see this all come together and happen. So it's pretty exciting to see what a complete different type of ecosystem we've built here with this community, and it was completely by accident, and we're quite pleased with the way it turned out. So the OSM architectural principles, these are our 4 core principles since our release 0, since the project first began. We like to have a layered architecture in that we're able to have abstracted layers and different modules that have very specific purposes. Instead of just having one giant code base that we call an orchestrator, we have very separate functions within that code base that can be changed and modified independently of each other with very well-defined interfaces in between them. And so we're able to be a lot more agile, and certain modules are going to iterate and innovate a lot faster than others just by their very nature. And that speaks to the third concept of modularity. We like to keep these different factions separate within the code base so that we can not only have a smaller code base to maintain for each individual function, but it also allows us to scale the project a lot more rapidly than we normally would be able to if it was just one giant code base. And finally, simplicity. We use standardized interfaces. We try to adhere as closely as we can to the ETSI standard models so that people know what they're getting when they use open source Mano. So that when we refer to certain interfaces, these are concepts that are really well documented and really well known throughout the global community, not just inside of OSM. So we try not to keep, we try to keep tribal knowledge and proprietary type architectures, designs, and code. We try to keep that out of the platform so that we can invite them, as many people as possible, to join the community and contribute back in. So the OSM ecosystem, Francisco Javier touched on this. This is the number of different companies, entities, academic researchers, et cetera, that participate in the open source Mano project. It's an opt-in process that we touched on earlier, and it's completely open. It's very easy to join. A lot of companies joined us as observers for one full release cycle just to see if it's for them. And then we're very happy to see that a lot of them jump in the next release cycle, actively start contributing code, which is great. So here's the shot of the OSM ecosystem. Again, more companies have joined since the slide's been updated because it iterates so rapidly. But the whole goal of this very messy slide is just to illustrate just how popular this product is getting and how pleased we are to see it. We also have a lot of activity from the 5G research projects, particularly the ones coming out of Europe. Listed here are some of them. We're not going to go into detail about all of them, but these are 5G research projects that are funded by the European government to explore innovation in very specific 5G areas. And so all of these projects are using OSM as their orchestrator to demonstrate their capabilities. And the great thing about these projects is because they're composed of some very intelligent people that are currently working in the academic communities, they're contributing some of their code base back and making OSM even better. Our first innovations around network slicing came from one of these 5G research projects. That one came from 5G Tango. And so we're seeing more and more communities stepping up and not only using OSM, which is great, but they're contributing innovation and really interesting pieces of code back into the community and making it even better. So why is 5G research so important to OSM? Why are we so excited about this? Well, it drives the new features into the code base. New features are always great. It introduces new uses for OSM outside of basic telco NFV. That was really our goal when the project started, was for telco NFV operators to start deploying NFV and make it a little easier to go to market with those services. Now we're seeing OSM being used in a totally different way. For all of these 5G research projects to be able to demonstrate their capabilities as well as iterate on them, this is a use case we hadn't really thought of when the project first started, but it's pretty interesting. It broadens and enriches the OSM ecosystem. Now we have a really healthy academic participation in the OSM ecosystem, and we're able to push the innovation a lot further than we were able to previously when it was more operator and commercial vendor driven. And finally, it creates new avenues for collaboration. I can't even count how many new collaborative efforts have come out of the fact that these people are getting together at the OSM plenaries, at the OSM Hackfest, and meeting each other and saying, you know, I'd really like to try something with your software. What do you think about putting it together with mine and doing some POCs? What do you think about getting together and maybe building a new product together? This is, again, something we hadn't anticipated, but it was a very happy accident that it happened. We also have an interesting cross-collaboration with OPNFV. We participate, we're one of the first participants in the CI/CD pipeline, and the first use case that we deployed into that was our NSH-based SFC testing. So we were pretty excited to work with them on that as well. As I mentioned before, we try as hard as we can to align with the ETSI standards, but we're not, we don't use that as the Bible of what to do in an orchestrator. So what we do is we review the ETSI standards. We use those standards that make sense today. We use those standards that we can use today, and we send feedback back into that community to discuss why we couldn't use certain parts of the standards and what new standards we need to see added into those existing specs. And so this feedback, this cycle will continue going forward, I would presume forever. As long as both projects are active, this is a very healthy interaction that we have with them. So what this displays here is exactly which components of these standards we're currently consuming as of release 5. And this goes into a lot more detail if you were to read the End User Advisory Group white paper that's posted on the OSM website. The link's here. This deck will be made available to you as well, but this link is this white paper is very easy to find if you just go to osm.etsy.org, and you can find all of our white papers. And this one is an interesting read for those of you who are concerned about how we really line up with the ETSI standards. So when we start looking into the architecture, OSM is composed of both runtime and design time components. The design time components being the GUI and the UI design time tools, as well as the text-based design time tools to be able to create and manipulate those network services, those VNF definition files. And then we have our runtime components that has the network service orchestrator itself, the VNF configuration and abstraction layer, the resource orchestrator, which talks southbound into the Vim and the Sdn layers to be able to push all of these workloads down to where you want them to be at deploy time. The VNF configuration and abstraction layer also has some new components as of release 4 and 5 in the monitoring module, where they're able to do day 2 and lifecycle operations like monitoring the health of an existing running service and acting upon whether or not that service is healthy, being able to scale it out, scale it in, reconfigure it, manipulate it, etc. And then at the bottom, you'll see we have our Vim layers, and we're compatible with a number of Vims. And because it is a plugin based model, like I mentioned before, the possibilities are really endless in the number of VIMs and SDN layers that we can snap into. So as we mentioned before, it's a layered model. We look at the different layers of services and different platforms that compose them, and being able to have this composable sort of Lego type solution is what makes this so flexible. And as I mentioned before, we really want to keep OSM simple. We want to minimize those integration efforts. And so we have a well-known information model. It's published on our website, it's published on the wiki. It's discussed in every one of our tech calls as we look at new ways we might need to modify that information model for the next release. It follows very close and is very well aligned with that CNFE, and so there aren't really foreign concepts. We didn't just pull this information model out of thin air. There was a lot of research into how we built it and why it is the way it is, and it should look very familiar to anyone who's worked with that CNFE and any of the IFA models that we've been working with previously. We unified the northbound interface as of release 4 into a Sol 5 compliant northbound interface, and so this was very key for us in release 4. Being able to have a standardized way to interact with OSM and being able to predictably define how that interaction is going to work, being able to reuse models because it's a standardized northbound API was very important to us. Previous releases of OSM, we had a sort of a proprietary API that was, I would say, somewhat incomplete. So now, by standardizing on Sol 005, we have a very clear direction. It's very well known what the capabilities are and what they are not. And it's very easy to be able to interact with it. And if you have existing integrations that are Sol 5 compliant, it's very easy to connect those into OSM now because of this northbound API. The concept of network service orchestration and network services that can expand multiple different domains. And what I mean by different domains are these 3 boxes across the bottom. The network functions, and those are virtualized network functions, physical network functions, or hybrid network functions, a mishmash of both physical and virtual. The transport domain, so we use the term WIM here. For those of you who aren't familiar with that, that's a wide area of VIM, so VIMs that exist in multiple geographic locations. And then we have the standard virtual domain, or the VIMs. And so being able to orchestrate across all 3 of those seamlessly without necessarily concerning yourself with the mechanics of those various components, because all of that is abstracted northbound by OSM, it makes it very easy to orchestrate and manipulate those network services. And finally, OSM is a network orchestrator, a network service orchestrator. And so if you look here in this diagram, this sort of reiterates what I just said previously, that we have our network service orchestration layer that holds all of the various configurations for those network services. And it abstracts from being able to do what you need to do in the VIMs to make those network services live and be able to keep them running. So open source Mana works as that abstraction layer to be able to talk to your VIM layers, talk to the SDN layers, talk to the WIMs, talk to the network services, et cetera, and being able to not only deploy them on day 0, which is a feat in and of itself, but be able to keep those services running, monitor them, and know how well they're running with the day 2 lifecycle management operations. And so when we look a little bit closer into the VIM layer, we'll see that OSM follows those Etsy standard interfaces here, the ORVI. These are well-documented interfaces into how they're supposed to interact with that VIM layer, and so we adhere to that. You'll see also here we have, and I'll get to this in a later slide, I believe, with the integration with the Sdn Controller. We have 4 different models in being able to integrate with the Sdn controllers, because as we all know, Sdn is a pretty broad ecosystem that do a lot of different things. Some implementations of Sdn are purely hardware-based, and it's just a standardized API that you talk to. Some implementations of SDN are completely abstracted by the Vim layer, and so you can only manipulate them by talking to the Vim layer. Some of them are a mishmash of the two, and some of them, and the fourth one you'll see here, this is something that's particular to open source Mana. We call Sdn Assist. And so we're able to do manipulations to certain SDN layers like ONOS and ODL that don't necessarily have direct connections through every Vim. So you know this, there are plugins into KVM-based OpenStack, like the ML2 plugin, to be able to talk to this, but no such plugins exist for vCloud Director example. And so building this extra shim layer that give you those same SDN manipulation capabilities, regardless of what Vim you use, is what makes OSM so flexible here. So OSM Release 5, this is sort of a quick overview of the journey of OSM. You'll see that only in the beginning of 2016, only 3 short years ago, was when we started on this journey with Release 0, and that was really mostly just code seeds and a barely functional orchestrator. Over the past 3 years, we've had 5 releases, a number of different plug tests, and a number of different milestones on the project, and now we've gone from 0 to production ready in being a fully functional orchestrator in less than 3 years. And now I'm going to get into a little bit about what happened in Release 5 that I think is so exciting. This was our most ambitious release so far, and we say this about every release because it's true. Each one gets bigger and bigger and bigger. We have more and more features. We have more and more capabilities, and those capabilities get a little bit more complex every time. As the code base expands, as the number of contributors expand, it becomes more and more complex to make sure that we still maintain the same quality of code, the same stability, and the same ease of use that we did from a much smaller code base. We now have support for hybrid network services, as I mentioned before. So both physical network services and virtualized network services can exist within the same network service, within the same definition. And so you can have hardware-based appliances with virtualized services combined in the same end-to-end service, and this can all be orchestrated seamlessly from OSM. In fact, in OSM, it doesn't really matter if it's a physical network function or a virtualized network function, because all of that is abstracted from the user. The data models are very clean and very concise and very simple to use. We've introduced network slicing for 5G. As I mentioned, that was a contribution by the 5G Tango team. We introduced multi-site inter-DC extensions. So this is that WIM model that I discussed, where you can have multiple data centers and one network service that spans all of them. We've had a number of monitoring and policy improvements, and I could speak for hours on the number of things we're doing in monitoring and policy improvements, but unfortunately we don't have the time today. But we've gone much deeper into being able to gather metrics from not only the application layer and the VNFs, as well as correlate them with what's happening in the Vim layer and the SDN layer. So only when you can get those metrics from all 3 of those components and correlate them together do you have a true picture of the health of your network service. This is something that wasn't previously possible in earlier releases of OSM, but it's now very seamless. And because we have a standardized plugin-based modular model for MON, we're able to plug in monitoring and telemetry from any system you can imagine. We already have a number of different integrations with different both commercial and open source systems, and so it's a really flexible, open-minded ecosystem for being able to monitor the health of your network services, so that you're not handcuffed to certain vendors or certain paradigms or certain methodologies. You can be as open and monitor your network services the way you want to and the way that makes sense for your business. We've improved the modeling of the Vnf networking in the way we have the multi-VDU, and when I say multi-VDU, I mean VNFs that are composed of multiple components, so it might be many VMs or many containers. We made that much easier to be able to build out and be able to build the data models for those network services. In previous releases, we could do this, but you had to have a little tribal knowledge on how to make it work within the data models. But now we made it much more obvious, much cleaner, much more easy to use. And finally, we improved the user experience significantly. We have a brand new UI that's very extensible that uses that northbound API. And so by doing so, we opened up the ecosystem for anyone to build their own UI that they wanted. And we already have a couple really great examples of what a UI can do and what it's capable of. But because it uses a standardized API, the same experience and the same behavior you get from clicking a button in the UI will be exactly the same as issuing a command from the command line. And we did this on purpose. We didn't want to expose any features that were only available in one or the other. And so now anything you can do with the API, you can do you can do in a UI, and you can do from the command line. So we've seen this slide before. These are the core themes for open source Mano for release 5. So as I mentioned, networking and slicing for 5G. This was a pretty big improvement for us because network slicing is not trivial, and being able to orchestrate it elegantly and simply was, again, not trivial. So this was a very interesting addition to the project. The multi-site extensions and being able to orchestrate network services that span more than one physical location was also pretty key. We didn't want to have to force an architecture where you had to have a unique instance of OSM in each data center. That really negates the whole purpose of orchestration. You want to be able to orchestrate the whole thing. And so by adding this, we make that possible. The monitoring improvements, as I mentioned, improved modeling and networking. So now you're able to model things like service function chains, physical deployment units, and multi-VDU relationships within a VNF, or all three of them together in one network service. This is, again, something that wasn't previously capable before release 5. And all of these user experience and optimization things that I mentioned. We've also packaged OSM much more elegantly. Previously, it was a bit of a pain to install. I will admit this. I will be the first to put my hand up and say, OSM used to be really hard to install. But we've made up for that and then some. Now it can be downloaded as a container, and you can go from zero to running OSM in under 10 minutes if you have a high enough speed connection. So we've come a long way in the usability and being able to deploy and get OSM running. So let's talk a little bit about the architectural components. Without going too deep, across the top we have the OSM client. So this is our command line interface, which, as I mentioned, uses that Sol 5 compliant northbound API. Right beside it we have our lightweight UI and composer. And as of release 5, we now have a UI-based composer that will be even more elegant and contain even more features in release 6. But you'll see here that the two of those are side by side for a reason. They both have the same functionality and capabilities because they both use the same northbound API. And so by doing that, we really level the playing field, and it doesn't matter which interface you like to use. You use the one you like. And also, if you would like to use that Sol 5 API directly because you want to integrate with an OSS system northbound, you can do that too. Then when you drop down a layer, you have LCM, which was what we call our lifecycle management area. And inside that, you'll see that we have our OSM IM, that's our information model. That's stored in the database. It exists in the northbound API. It exists in the lifecycle management module. It exists in the resource orchestrator because the information model touches all of these various components. So the lifecycle management module, it's pretty self-explanatory. It takes care of the lifecycle management of your network services. Things like starting, stopping, restarting, scale in, scale out. More or less all of the basic things that you can do with a network service is all controlled from here, from the lifecycle management module, and how it integrates with the VCA here. This is something that's unique to OSM. This is something that you're not going to find in other orchestrators. The VCA engine is provided by Canonical's Juju. And in using that engine, we've created a very flexible framework to be able to do anything you can think of to a VNF. If you're able to connect to it, you can reconfigure it. You can scale it out, you can scale it in. You can identify relationships between multiple VNFs so that if you have a complex architecture like 3 nodes behind a load balancer and you want to scale it out, you need to be able to notify the load balancer that there's a new node. You need to be able to notify the other nodes that there's now another buddy within their ecosystem there. You can do all of this with the VCA. And this is something that makes OSM very, very powerful. It's as powerful as you take the time to program it to do things. Beside that, we have our resource orchestrator, and as I mentioned before, this is the bit that talks to the Vim layer. This is the bit that talks to the SDN layer. This is the stuff that talks to your infrastructure and tells it, I need a VM that has this many virtual CPUs, and I want you to put this piece of software on it, and I want you to create a network and attach it to here and here and here with these types of interfaces, with this type of security model, et cetera, et cetera. So this is the module that does all of that negotiation configuration with your Vim layer and your SDN layer. And then along the side here, we have something called Paul that I haven't mentioned previously, and Mon. Mon is our monitoring module, which I did talk about. But Paul is our policy engine, and this is something that's new in Release 5. What the policy engine allows you to do is set policy for things you want to happen in your lifecycle management of your network service. And so while it's all well and good that you've defined all these relationships between your various components, the policy defines when and what they need to do. And so in policy is where we define if a certain KPI threshold for performance is violated, restart or scale out or et cetera, anything you'd like to do. So this policy engine, we're going to see a lot more capabilities in that in Release 6 as well. It really makes OSM completely flexible into being able to automate and make your infrastructure truly zero touch, in being able to not only deploy those network services, but have them do things like self-heal and self-monitor and self-scale out. That's where this capability really gets relevant, and that's where it really gets exciting going forward. And so looking a little more at the microservice type architecture, we do this on purpose so that we can be very flexible. And you'll see here that we have a very flexible architecture here where we can have these different components that are all part of OSM that can interface with different open source components or commercial components here. You can add your own stack here for monitoring. So we have our performance monitoring stack with Prometheus and Grafana to produce elegant graphs over time that show you exactly how your service health is doing. We have the ELK stack to be able to modify and manipulate your existing logs and use those to fuel the policy engine to do things on your behalf without having to sit there and watch your monitoring system and wait for something to turn red or wait for the graph to take a nosedive. These systems all integrate very elegantly together because of the plugin model that will allow you to start driving these self-healing operations, these zero-touch operations. So let's talk a bit about network slicing. So this is something that popped into Release 5. Yep, so let's talk about, I jumped ahead a bit. So the network slicing will come next, but these ones are auto-playing, that's interesting. Okay, let's talk about SFC then. So as of Release 5, SFC has a lot more features. We had some SFC capabilities as of Release 3 as an experimental feature, but we flushed it out. It's available using OpenStack Queens or later. Right now, it currently supports only asymmetrical chains, and I'll talk a bit about what that is in a second. And it uses the NSH service encapsulation headers. So those of you who are familiar with SFC architecture, it uses the NSH technologies to make this possible. So as I mentioned before, the SFC was the first thing that we used as part of the cross integration with OPNFV, and it was one of the first things that was tested. So as of October 31st, 2018, we had this SFC working as part of the test automation with OPNFV. And so this is an iterative automated test that runs periodically that will tell us, it's part of our CI/CD pipeline as well as connected to the OPNFV CI/CD pipeline where it'll actually check our new code out of our GitHub, do all the build steps it needs to, and run a test against it and give us instantaneous feedback. So that's pretty exciting for us too. So when we talk about SFC, we currently support asymmetrical chains. And what I mean by this is one path going one direction. The reverse path would be defined as a separate asymmetrical chain as opposed to just merely being implied. being able to do backwards and forwards symmetrical chains is something that we're slating for a future release. Probably release 6, but it's an open source community, so we'll see. Other things that are slated for release 6 and beyond are non-transparent service functions, and so being able to interact with VNFs that are not SFC aware, that is, VNFs that are not able to read those NSH headers and be able to manipulate them. Branching and joining, so being able to dynamically change a service function chain that's already been defined without having to tear it down and redefine it. This is something that's also slated for a future release. Service function tap, and being able to copy something that's happening in an existing chain and punt it off to another VNF. This is something that's slated for a future release as well. So the Sfc Management Api, it adheres to relatively static and coupled to network topology and physical resources. So what we mean by this is it allows us to create dynamic service chains with existing infrastructure and being able to change your network path without having to redefine your network. And so what that means to OSM is that we have a single point of entry here with OSM to be able to define those SFC chains and being able to manipulate those different network paths, as opposed to the traditional way of doing it, which has a number of different touch points you'll see here. Now we're going to talk about network slicing. Okay, so for those who are not aware of the technology, network slicing is simply using the same physical network and the same virtualized network to have a number of different functions that run across it, and being able to segment those functions from interfering with each other and applying a certain quality of service across those network functions. So the framework for network slicing is what we use in OSM. A network slice subnet is more or less considered a subset, or a network slice subset is considered an NFV network service. And so to compose a network service, you can combine a number of network slices together. And so in essence, we didn't have to make many changes to the information model to be able to make this possible. When we really looked at what a network slice is and what it does and what we needed to do, we saw that just by making this simple nested architecture, we already had all of the framework and the pieces that we needed to make it possible. So the network slicing in OSM, the major development, as I mentioned, it came to us from the 5G initiatives. And the two key attributes are the composition of the network service and being able to share a single network service instance between slices. That's pretty interesting. So if you have a network service defined that defines your network pipe, you can have multiple network slices that leverage that. That's the whole point of network slicing, is to be able to have these different capabilities using the same network without interfering with each other. And we're also able to achieve a certain level of dynamic behavior between the network, across the network service with the various network slices, and we can pin up new ones, tear down old ones. We can manipulate and modify different components without having to destroy the whole architecture. And so this is just a little bit of an illustration of the life cycle of a network slice instance. It's a little bit hard to read here, but it shows here the different components as well, where the network slice instance contains the network functions, the information relevant to the interconnections between these network functions, very similar to service graph, and the individual link requirements, like the quality of service attributes. And so all of this, for those of you who are very familiar with network slicing, all of this should be pretty standard stuff. And so what we've done is we haven't gone too far off the reservation with how we've implemented network slicing, but we've done it in a very standardized way. And this is just a diagram of how network slices can be realized. Again, this deck will be made available because I understand this is a bit hard to read. So these are some of the assumptions that we've made for network slicing within OSM to make it possible. A network slice subnet is supported by a network service. Whether it's shared or not, there has to at least be a network service before you can put a slice on it. That's pretty obvious. Network functions can be physical or virtual, or a combination of both. Your network, the actual network service that you're pushing the slice over, can traverse a number of different components. We include 5QIs as a constraint. There are two types of information model resource for supporting slices. So as I mentioned, we only made minor adjustments to the information model, and that is to include the network slice template and the network slice instance. That's it. Those were the only things we really had to modify in the information model. The network slice template will have connection points, as I mentioned previously. The network slice service can be interconnected with virtual links, which are described as a network service forwarding graph. And then these are the objects that we use to define them in the information model. I'm not going to go too deep into the information model because I'm already kind of over time. So we introduced the API. In release 6, we're going to be extending the northbound API to be able to do more with network slicing, being able to manipulate it. But right now, these network slices can be defined and deployed through that northbound API because they exist in the information model. And so, as Francisco Javier mentioned, if you'd like to participate in OSM, our next event is the 6th Hackfest. That's going to be happening in Santa Clara, California. We're also going to be having our first OSM VNF Day, where we're inviting a bunch of the VNF vendors that have participated with OSM to come and talk about how OSM is relevant to their work and the work that they've done in the community. So, we do not have any time for questions because we're now into your break. However, if any of you would like to chat with me during the break, then feel free to catch me as we're getting coffee. Thank you.